How you doing? Welcome back to Sunny Charlie. We're off to have a look at a modification on a Toyota Mark II, I believe it's called. Let's go and have a look. Hello and welcome back to North West Propshafts. First of all, I think I've got to thank Barnum Engines. I don't know if you saw the last video or not, but we manufactured a bike engine kit car shaft. They saw the video, wanted to have one of the prop shafts, so sent it down there. They said our name on their YouTube channel. They've got a lot of subscribers on their YouTube channel, and we've ended up having 1,800 views all about prop shafts, which has surprised me massively. So thank you very much to Barnum Engines. Go and check them out. Engine reconditioning, head reconditioning, boring and such. They have some very good videos. Lots of them as well, so you can find anything that you want on there. But today we're looking at a Toyota shaft that's been sent in to us. Not only do we just make shafts, but we also modify them as well, so it's a cheaper option. So we've got a Toyota Mark II, probably the one of, if not the highest and longest running production model of Toyota over in Japan. I think it's ran from something like the 60s, 70s right up through early 2000s, I think. Anyway, this gentleman has come from a company that modifies some vehicles and does some work on them. Sent us up a prop shaft. They're taking out the automatic box and putting in a manual box. So it means the prop shaft is the wrong length. So I'll just turn the camera in so you can have a look. So this is the prop shaft here. The customer has taken out the manual box, automatic box, and putting in a manual box. On most vehicles, whenever you've got a manual version or an automatic version, a lot of the time the prop shaft is the same. The only difference is the actual length. So this customer has actually supplied this to us, which is a 55mm insert, and he's asked us to cut the prop shaft in the middle and put this insert in. Now, we have a few issues with that. It's not the best way of doing it, and I'll show you a few reasons why. So the main reason that we don't like doing this, putting an insert in like this in the middle of the prop shaft, is obviously we've got to cut the prop shaft and put this in. So we have tube on this side and tube on this side. So there's 55mm between these two welds. Any weld generates heat, so as soon as we put a weld round here, that heat goes through the actual piece of steel and expand through. So all this will start warming up. When we come to put our second weld through here, these two cool at different rates, so the actual unit can bend a little bit. Now, when we're making prop shafts, we work to a tight tolerance over the full length. So we'd rather put a new tube in it, so it's like all the way over here and all the way over here. The two welds the heat doesn't transfer to the opposite side. It is possible we could weld this, wait half an hour, then weld this, then wait half an hour, but as a production facility, and it being on our welding machine, that machine out of commission, taking up time, and time costs more than some components do, especially with prop shaft tube like this. So what we're actually going to do is cut the prop shaft here, cut the prop shaft here, machine the ends to the right diameter tube on either side, and then put a new tube in it. So let's go and get that done now. Right, so we need to put 54mm in. This unit is 54mm, so we'll measure it up so we know what our finish length is, what our start length is, and what our finish length is. And we're putting 54mm in. When we're doing this, we tend to use fixed points on the shaft. So a fixed point is the flange at the end there, and a fixed point here is the center line of the UJ that's attached to the tube. Not the one that's attached to the yoke, the one that's attached to the tube. So we'll take that as our fixed length. That won't move, and then we'll add 54mm to it and go and chop it. Let's go and chop it. So that's the sleeve chopped up. We leave around about 4 inches on the end so that we can get it in the machine for turning. Now this, if you look, this is a friction weld. This isn't a normal a normal weld, like a normal MIG weld. Basically, these two pieces are put together and then forced under pressure and speed to create this friction weld. You see it a lot on pipe welds, on plastic. See it on quite a few prop shafts. It's a quick way of putting things together in a production setting. A quick way of things putting together in a production setting. But it means that you tend not to have any material on the underneath. So like, whereas this insert has got this material on the underneath here, where that would go inside the tube. In fact, that's not a very good fit. Oh, it probably will be. Where it would go inside the tube. This gives you a weld face to weld to. But fortunately, if you can see down there, you see this the silver ring. That's actually this part here, which is a little bit thicker. So we can machine this part down and create that bung. So instead of the friction weld, where the friction weld is there, when we actually come to weld it, the weld will be more like in halfway down that. So it gives us a little bit of a bung to put underneath. So we'll go and have a look at the machining process. So here we go, this is the machining process. This is actually the centre bearing, this is the other end of it. So we're just going to make a clean face. The tube that we're going to use is 60mm diameter, 2mm wall thickness. So we'll just check what our starting diameter is. And then we'll machine down a stub, what we call a little stub, which is the bit that goes inside the tube. And create the component so that it can go back inside a piece of tube. We'll just speed this a little bit up now for you. So we've got the components back in here now. This is the mid-assembly. So if you see, we've got the section that goes inside the tube, and now a weld face. So the weld is going to be here. That's all machined. We're going to clean this up a little bit. We would like to clean the easiest way to clean these is sandblasting, but we can't with this because the centre bearing here we don't want to get sand inside. So to clean these up a little bit, just to prep it before we weld it, and to make it look a little bit cleaner for spraying later, we're gonna laser clean it. We have a laser cleaner. So we'll get the laser cleaner set up and just clean this off a little bit so you can have a look at what the laser cleaner does. So this is our laser cleaner, a bit low because we've got extraction. To get under the extractor, there we go. So this is just cleaning off all the rust that's around the weld face that we can't get to. We can't sandblast that off. So we'll clean it using this. So just clean around where the bolts go, around the bottom. It does cause quite a lot of smoke, so that's the extractor that you can hear. So there we go. Just knock the so as you can see, it's just cleaned it all up, taken off that surface rust so that when we come to paint it, it'll look a little bit nicer. And it's easier to weld without the surface rust, without grinding away at anything or taking the rust off with sand, which can ruin these centre bearings. While we're at it, we'll just clean the top face up as well. Doesn't really need it, but just to show you what a laser cleaner does compared to sandblasting, really. There we go. We'll just knock the just turn the extraction off. But as you can see, it cleans it up nice and smooth. So it gives a better surface to bolt to. But that's what we use our laser cleaner for, rather than sandblasting. Right, so into the workshop we go. Let's put some tube on these and get it into the balancing room. We're back in the workshop now, and we've got the tube cut, and we're going to press the components in. So we'll just show you the components. So here we go. We'll just press the what we call the mid-assembly in on the hydraulic press. So in goes the mid-assembly. We don't need to line this up with anything at the moment. We can just press this in nice and tight. There we go, inside the tube. And we'll put the other end in next. Use the workshop. So there's the shaft complete. I missed him putting the front end in because I went for a wee. So instead of having this insert now, anywhere on the shaft really, doesn't really matter, wherever he wanted it, but instead of that, having that insert in now with 4 welds, 1, 2, 3 and 1 at that end, 4, we've just got 2 welds. So 1 weld here, 1 weld here. There's no chance that we've got any problems going down it. We'll be able to get it nice and straight because we've got plenty of distance between the welds, so no heat transference whatsoever, so we can get it all nice and straight. Off it goes into the balancing room for welding and balancing then. We had some comments on our last post, which was brilliant to hear. Some comments, or even asking questions. So please have a look down in the comments, ask us some questions if you've got any, give us some comments if you've got any, but please remember to like and subscribe so you can see more of these videos if you're interested in them. So not only that's a small Toyota shaft on a small 60mm diameter tube, but we can go right up to 180mm diameter tube, which we do on quite a regular basis. There's actually some just behind me here, that have been machined. Those are 120mm tube. They started off at about 1 metre long, and they've been extended for a customer. And we've got all sorts of tube. You can see it behind me here on all the racks. Lots of different sizes and types of tube. We keep, so I think it's somewhere around about 5,000 metres, I think it's 4,500 metres last stock check last week of tube in stock of various different sizes. So we can always extend and modify anything here. Right, let's go and have a look how this shaft's getting on in the workshop with the balancing. Well, let's go back into the workshop and check if this shaft is on the machine. Let's have a look. You cleaning? Well, are you gonna put this on after dinner? What time is it now? What time is it? Oh, is it? Oh, fuck! I thought it was later than that. Are you gonna put it on shortly?
Yeah, I'll put it on before.
Give us a shout when you're putting it on then. All right. The shaft's now finished, it's been painted and is going to be boxed to go back to the customer. We'll just let you have a quick look at it now that it's done, see how it turned out. Here we go, this is how the shaft turned out. So obviously we had the friction weld here, machined back, and the new weld there. And the same at this end, the friction weld was here, friction weld was here, new weld here, all turned out, all sprayed in RAL grey and ready to go back to the customer. As usual, if you've got any questions, please let us know, and please remember to like and subscribe. And if you want to see any more videos about anything else, I think maybe the next one that we do will possibly be on Land Rover shafts, about angles and heavy duty and the difference between heavy duty and standard. So I think we'll probably do that next week. But I hope you have a good week and see you next week. Bye bye.